So our first example video is just basically on how we can use our new notation to be able to solve these problems. So let's have a look at this problem. We've got find the equation of the tangent and normal to the curve y is equal to x squared plus 4 at the point p1 negative 1, 3 on the curve. So you guys should already know how to do this. We've done it in the last few lessons. Okay, all that's different is we're just using this new notation. So what we're going to start off by doing is differentiating. So differentiating. So if you have f of x is equal to, oh sorry, not f of x in this case, because, you know, why would we do that? We've got y is equal to x squared plus 4. So dy dx is equal to 2x. Okay, that's it. Okay, so at our point, our point in this question is at negative 1, 3. So at negative 1, 3, okay, we want to work out, well, what's the tangent of the curve, okay? So where x is equal to negative 1, so in this case, we're going to let dy dx be equal to negative 1. So that is with 2x, dy dx also being equal to 2x, so we get negative 1 is equal to 2x. And so we get that x is equal to a... Sorry, doing this the wrong way around. What we're going to do is we're going to substitute... We're going to sub x is equal to negative 1 into this equation up here to get what the derivative or the gradient is at that point there. So dy dx is equal to 2x, so we're going to go dy dx is equal to 2 lots of negative 1, which is equal to negative 2. Okay, so the tangent at P has gradient negative 2, and the normal has gradient a half, because, you know, the gradient is just the negative reciprocal of negative 2, so in this case it's half. So to write the equations, okay, so the equations, so therefore equations are, and we'll start with the tangent. So the tangent's going to be, so y minus y1 is equal to m lots of x minus x1. So whenever we want to find the equation, like it says in the question, find the equation. Okay, so we're going to use that. I'm going to use a point, and our point is negative 1, 3. So we're going to substitute our values in. We're going to get y minus, well, it's going to become plus 1, is equal to, now our gradient was negative 2 for our tangent, so x minus 3. So y plus 1 is equal to negative 2x plus 6. So y is equal to negative 2x plus 5. Okay, that's the tangent. So the equation of the tangent. And the normal. Okay, so the normal, we're going to do the same thing. We're going to use y minus y1 is equal to m lots of x minus x1. Okay, so now that we've done that, y minus, we're going to use the same point again. The only thing that's going to change is that our gradient, instead of being negative 2, is going to be a half. So x minus 3. Okay, so y is equal to, in this case, it's going to be a half x. Now it's minus 6 on 2. It's going to be minus 3 on 2. So adding 1, which is 2 on 2, we're going to subtract 1 from both sides. And you know what? I'm going to write it this way. Minus 3 on 2 minus 2 on 2. So y is equal to a half x minus 5 on 2. Okay, and there's our equation for our normal. So again, it's the same thing. The only thing that has changed is that we're using this dy dx notation to find what our derivative is. Okay, so nothing has actually changed, just the notation that we're using. So with that being said, that's going to be the end of this video. Nice short one, just using our dydx notation. And what we're going to do next is we're going to find a tangent passing through a fixed point.